It is Thursday night, 6:31 p.m. on the 12th of February, 2026. You are looking at Messier. Ooh, it's either 35 or 36. Let me go and check it out. Messier 36, open cluster, magnitude 6, 12 arc minutes in size, 4,100 light years distant. RA is 536.17 with a declination of plus 3408.27. Okay, I'm going to plow through a few of the more northerly studies and give the sky a chance to clear up a bit. Looking at the geo-orbiting Earth satellite image, it should get better for about an hour, as I mentioned earlier. This next northerly study is NGC1800 open cluster in Taurus, magnitude 7, 17 arc minutes in size, another 20 stars or so. The brightest are magnitude 8.6, as you can see. It's a class 2-2, which means fairly condensed and fairly similar magnitudes. 3,100 light years distant. RA is 5 hours, 10 minutes, 43 seconds, with a declination of plus 16 degrees, 31 at 18 seconds. Okay, skipping some 50 studies into the second half of the evening is NGC 1857. It's an open cluster in Auriga. Magnitude 7, 6 arc minutes in size, 40 stars, a little more condensed than previous open clusters. Magnitude 7.4, there's a bright one right in the middle. Who knows whether or not it's actually part of the cluster. Another class 2-2, relatively condensed with a relatively tight variety of star magnitudes. However, this one is very distant, 18,900 light years. I kind of doubt that magnitude 7.4 star is really in the cluster. NGC 1857. We're at right ascension 5 hours, 20 minutes, 5 seconds with a declination of plus 39 degrees, 19 minutes, and 30 seconds. NGC 1893 is another cluster, but there's some nebulosity associated with it. I'm seeing a little bit around this one star there. It's considered a nebula and open cluster in Auriga, magnitude 7.5, some 60 stars, and it's given brightest or magnitude 9.3. It's class 2-2 again, fairly condensed, fairly similar magnitudes, but 10,700 light years distant. Remember, we're looking out away from the Earth 10,000 light years, so this is about 35,000 light years away from the core of the Milky Way. We're at right ascension 5 hours, 22 minutes, 45 seconds with a declination of plus 33 degrees, 24 minutes, and 42 seconds. See if we can pick up a little bit more of that nebulosity. Oh yeah, it's spreading here, there, and probably immersed everywhere in NGC 1893, but very diaphanous. Here we should be seeing NGC 1817, an open cluster in Taurus. Nice sprinkling of stars. It's a class 3-1, so they're pretty spread out, but they're all supposedly a very similar magnitude. The brightest star is magnitude 11.2. The collective magnitude is 7.7 with 16 arc minutes in size, some 60 stars, 6,400 light years distant. RA is 5 hours, 12 minutes, 15 seconds with a declination of plus 16, 41, 24. I could have picked this one up on the way south, but I didn't include it in my early viewing list. Here we should be seeing NGC 1819, and I believe it's right there and centered up in the field now. It's a galaxy in Orion, the first of the evening, magnitude 12.4, 1.7 by 1.2 arc minutes. We'll go to our 105x view. Spiral with a bar, lenticular class, 200 million light years distant, puts it at probably about 110,000 light years in diameter. RA is 51146 with a declination of plus 5 degrees, 12 minutes, and 1 second. On to another diffraction bar galaxy, and I do believe we just caught it outside the sprawl of the diffracted light from a power line. This is NGC 1832, quite a leap, yes. Galaxy in Lepus. Well, makes sense to have a big leap in Lepus. Magnitude 11.3, 2.3 by 1.5 arc minutes, spiral with a bar, lowercase bc, and an annularity. So let's first take it up to maximum. I do believe we're almost making out its frontier, annular frontier. Use all those pixels, and there is our NGC 1832. 85 million light years distant, probably some 50 to 60,000 light years in diameter. It's at right ascension 5 hours, 12 minutes, 3 seconds, and a declination of minus 15 degrees, 41 minutes, and 18 seconds. NGC 1843, pushing it up to 50x, is probably right about there. Let's see if it matches with this data. It's a galaxy in Orion, magnitude 13, 2.1 by 1.7, football-shaped galaxy, spiral lowercase c. Yep, not much of a core on that, sweetie. 116 million light years distant, probably puts it about 70,000 light years in diameter. RA is 5 hours, 14 minutes, 6 seconds with a declination of minus 10, 37, 37. Nice to see we're tracking well tonight. The focus was pretty pristine. I did have to adjust it, however, this evening. Okay, here we should be seeing NGC 1875. It's a galaxy in Orion. There's one there. It's magnitude 13.6, 1.5 by 1.5 arc minutes. Let's take a look at that. Yeah, it does seem to have a bit of a 3:1 aspect ratio. It is lenticular class, spiral O, 402 million light years distant. This one's probably about 180,000 to 190,000 light years in diameter. RA is 5 hours, 21 minutes, 45 seconds with a declination of plus 6 degrees, 41 minutes, and 18 seconds. Okay, once again, we've gone pretty deep south where the cloudification is thickest. We're after NGC 1886, a galaxy in Lepus, magnitude 12.8. This should be a beauty. I'm going to recommend you go to theskylive.com and track it down, because it is 3.1 by 0.4 arc minutes, and that's about an 8:1 aspect ratio. We can only hint at it here at 150x, and I believe it is here, and there are several other galaxies in the field that you might want to have a look at. This one's a spiral with a lowercase bc, so not a very pronounced core. The core should blend into the spiral arms. 75 million light years distant, puts it at about 70,000 light years in diameter. RA is 521 at 48 with a declination of minus 23 degrees, 48 minutes, and 41 seconds. NGC 1888, probably that one there. Let's check out the characteristics. There are several others in the field. Is a galaxy in Lepus. Yes, this is it. It's magnitude 11.9. It's a rightish. 3.2 by 1.2 arc minute. You can see the extensions there. Pretty much a little less than a 3:1 aspect ratio. Pushing it up to our favored magnification of 105x. It's a spiral with a bar and peculiarities. You can see the handedness in it. It's tending off to the southeast spiral arm, but the northwest spiral arm isn't nearly as pronounced. We're at right ascension 5 hours, 22 minutes, 34 seconds with a declination of minus 1130 aught. Okay, NGC 1889 is also in the same field. However, it's magnitude 14. Ooh, maybe that's not a star. It's an elliptical class O. Oh, now we understand this relationship. Distant 110 million light years. I do not recall what the last NGC 1888 was. Right ascension is 5 hours, 22 minutes, 35 seconds with a declination of minus 11 degrees, 29 minutes, and 49 seconds. Okay, we're back up to NGC 1893, that nebula and open cluster that we imaged earlier. We noticed this nebulosity to begin with, but it took several stacks to start revealing the nebulosity attendant with this group of stars here, and we're getting it. It's magnitude 7.5, 11 arc minutes in size, 60 stars, magnitude 9.3 of the brightest. It's a class 2-2, a beautiful middling open cluster, not highly condensed, but not dispersed, not with a great deal of uniformity in magnitude, but spread out a little bit to give some variety. It's 10,700 light years distant. RA is 522.45 with a declination of plus 33.24.42. Now I'm going to let this develop a little bit and see if there's any more studies. And what we'll do is we'll come back to this and 1888 if there is not. There's a group of stars in Auriga, but I think we captured it. The next one is 1904. So let's stay with this and let's do a 30-second exposure on, I think it was 1895. Let me go and make sure I've got that as we stack a few up in this nebula open cluster. Okay, I thought I'd let it pop. We're now completing our current image with 3 stacks, but there's really only one at 30 seconds of NGC 1893. I think I'm going to pause it and allow at least another stack, but I want you to watch as each stack is added by pausing, and then I'll resume. You just saw that next stack occur. Let's go ahead and push the magnification up to 45x. We've got a really beautiful centering on this cluster and nebulosity. Quite a lovely NGC 1893 nebula open cluster in Auriga. Magnitude 7.5, 11 arc minutes, 60 stars, brightest magnitude 9.3, class 2-2, 10,700 light years beyond our own solar system, so about 35,000 light years out. RA 522.45 with a declination of plus 33.24.42. We've had 5 stacks now. I love this cluster, but let's go take a look at NGC 1888, those galaxies, one of which was quite edgy on. Center up the galaxy, NGC 1888 and 1889. We're supposedly going to have 4 stacks right now. None have been ignored. The total exposure time of 120 seconds. And I am going to allow 1 further stack to occur before we carpe noctem out at roughly 7:15 on the 12th of February, 2026, and it is a Thursday evening, and we should see the stack. Come on, baby, you can do this. Come on. Okay, stack finished. Time used 2 seconds. NGC 1889 is that very close galaxy in Lepus once again, but it's magnitude 14.6 by 0.4 arc minute elliptical class O, and I'm assuming this is it right here. 110 million light years distant, RA 522.35 with a declination of minus 11.29.49. I'm going to go back to 1889 and see what the distance was for it. Remember, 110 million light years distant. I'll go back. And the handset is telling me it's 115 million light years distant based on the red shift. This one's about 4 million light years. The Aegean is 4 million light years more distant than the elliptical galaxy we are seeing right neighboring the core. So we're getting pretty much a line of sight view encompassing both the Aegean and the elliptical. And with that last observation, I am going to say carpe noctem.